Greetings of the day, students. I am Dr. Jisha Mishra and I cover the lecture is the introduction of transistor and BJT. First of all, we will discuss what is transistor. Transistor is an electronics device made of three layers of semiconductor material that can act as the insulator and conductor. The three-layered transistor is also known as the bipolar transistor. In the figure, we can see how the look the transistor is, the structure of transistor. Now we discuss the difference between diode and transistor. First of all, we discuss the definition of diode. A diode is two-terminal semiconductor switching device which allows current flow only in one direction. The other hand, a transistor is their terminal semiconductor device which is capable of switching and amplifying the signals. Now we discuss about construction of diode. A diode is constructed by joining a p-layer semiconductor material with an n-layer semiconductor material, and the transistor is constructed by sandwiching either a p-type semiconductor between two n-type semiconductor or an n-type semiconductor between two p-type semiconductor. Number of p-n junction. Diode has one p-n junction, transistor has two p-n junction. Terminals. Diode has two terminals named anode and cathode. Transmitter has three terminals, emitter, base and collector. Types. There are various types of diode such as signal diode, power diode, Zener diode, LED, etc. Transistor are mainly two types, BJT. BJT stands for Bipolar Junction Transistor, and FET. FET stands for Field Effect Transistor. Depletion region. There is only one depletion region in a diode at the p-n junction. There are two depletion region in a transistor. Type of element. The diode is a passive circuit element. Transistor is an active circuit element as it can provide amplification in the circuit. Modes of operation. Diode can operate only as a switch where closed switch in forward bias and open switch in reverse bias. Transistor can be operated as switch as well as amplifier. In active region, it operates as an amplifier, while an saturation region as closed switch and it cut off region as an open switch. Switching. A diode perform uncontrolled switching, a transistor perform control switching, where the controlling is provided by base signal. Applications. Diode finds application in electronic circuits such as clamping, rectifier, voltage, multiplier, etc. Transistors are used as an electronic switch amplifier, oscillator, regulators, etc. As it's seen that these are the application of transistor. In the figure 2 presents the application of transistor, and we can see that the application of transistor, one of amplifier and second one is switch. When the amplifier weak signal enter in transistor, so we can recognize that weak signal convert into strong signal, and the same for switching application also. For switching application, weak signal convert into strong signal. Now we discuss what is BJT. BJT stands for bipolar junction transistor. Bipolar junction transistor invented in 1948 at Bell Telephone Laboratories. As here in a new era of solid state circuits, it was replaced by MOSFET as predominated transistor used in modern electronics. Three terminal devices are more useful than two terminal ones, such as the diode, because they can be used in a multitude of applications. First one is signal amplification, second was a design of digital logic and memory circuits. The basic principle is the use of the voltage between two terminals, the control of the current flowing in the third terminal. In the way, a three terminal device can be used to realize a controlled source. Important fact about BJT: there are two p-n junctions, hence a transistor may be regarded as combination of two backward connected diodes. The collector region is wider than both ammeter and base. The base is much thinner than both ammeter and collector. During the transistor operation, a lot of heat is generated at the collector. Hence, the collector is made larger to dissipate the heat. A transistor has three sections of doped semiconductors. The one section is called the emitter, the other is called collector, and the middle section is called base. From two p-n junction between ammeter and collector. In general, the ammeter base junction of the BJT is made forward biased, whereas the collector base junction is reverse biased. The resistance of forward based junction is very small as compared to the reversed base junction. The ammeter is heavily doped so that it can supply a greater number of charge carriers. Charge carriers are electrons or holes to the base. The base is lightly doped and very thin, hence it passes most of the charge carriers injected by the ammeter to the collector. The doping concentration of the collector region is moderate. The basic of electronic system nowadays semiconductor device. The famous and commonly used of this device is BJT, bipolar junction transistor. It can be used as an amplifier and logic switches. BJT consists of three terminals, First collector, second one base, a third one is ammeter. Two type of BJT, either NPN or PNP. In this figure shows the physical structure of NPN. In this figure we see the first one, the left side is ammeter, the right one is collector, and the middle one is base. You can see the base region is small thin as compared to ammeter and collector, and the base is connected to ground. Now the rightmost side we can see the circuit diagram of NPN transistor. In the circuit diagram, the top one is collector, the bottom one is ammeter, and the middle one is base. Device, structure and physical operation. The figure show the simplified structure of BJT. Consists of three semiconductor region. Ammeter region define N type, base region define P type, collector region define N type. Type described above the referred to as NPN, how PNP type do exist. Now we discuss the physical operation of PNP. So in this figure we can see the leftmost side P is ammeter, the rightmost side P is collector, the thinner side is base, and base is a N side. So we can say this one is PNP type transistor. In the PNP type transistor, ammeter and collector is a P type, base is a N type, and in the different side NPN is N ammeter and collector, both are different, and for the physical structure we can see the ammeter is a top side and the collector is a ground side, and base one is a middle of the transistor. In this figure we show the circuit diagram and what is the symbol of BJT. Base of the located at the middle and more thin from level of collector and ammeter. The ammeter and collector terminals are made of the same type of semiconductor material, while the base of the other type of material. Now we can see the P type PNP or NPN difference in this figure. The position of terminal ammeter, it's classify which one is PNP and which was is NPN. This is clear from the figure number 5. By imagining the analogy of diode, transistor can be constructed like two diodes that connected together. It can be concluded that the work of transistor is based on work of diode. In the figure shows the working of PNP transistor and NPN transistor. Now we deeply discussed about transistor circuit. As you can see the figure, the arrow is always drawn on the ammeter. The arrow always point towards the N type. The arrow indicates the direction of the ammeter, and the collector present by IC. IB is the base current and IE is the ammeter current. In the PNP, the circuit flow E to B, and for NPN the circuit flow B to E. E presents ammeter, B presents the base. Now we discuss about NPN transistor. In NPN transistor is the one in which two layers of N type semiconductor material and separated by a thin layer of P type semiconductor material. Hence, in case of NPN transistor, the ammeter and collector are of N type while the base is of P type. Now we discuss about PNP transistor. When a thin layer of N type semiconductor material is sandwiched between two layers of P type semiconductor material, the resulting transistor is known as PNP transistor. In a PNP transistor, the emitter and collector are made of p-type semiconductor material, while the base is made of n-type semiconductor material. Now we deeply discussed difference between NPN transistor and PNP transistor. Description: first, a type of transistor in which a thin layer of p-type semiconductor sandwiching between two layers of n-type semiconductor. In other hand, PNP transistor, a type of transistor in which a thin layer of n-type semiconductor sandwiched between two layers of p semiconductors. Now we discuss the terminal. In NPN transistor, the emitter is n-type base, is p-type of collector is n-type. Now in another hand, in PNP transistor, the emitter is p-type, base is n-type and collector is p-type. Now we discussed current direction about NPN transistor. In NPN transistor, current flow from collector region to emitter region, and for PNP transistor, the direction of current is flow to emitter to collector, means both are opposite for an current point of view. Majority charge carrier. Electrons are the majority charge carriers in NPN transistor, but for PNP, holes is a majority charge carrier. Minority charge carriers. Holes are the minority charge carriers in NPN transistor. Electrons are the minority charge carriers in PNP transistor. Both are opposite for minority and majority point of view. Switching speed. Switching of NPN transistor is faster due to high draft velocity of electrons. Switching speed of PNP transistor is low due to low drift velocity of holes. Switching time. The switching time of NPN transistor is small, but the switching time of PNP transistor is large. Active region operation. The most important difference between NPN and PNP is active region operation. The NPN transistor is said to be operated in active region of emitter, is connected to negative terminal of battery with respect to base, and the collector terminal is connected to positive terminal. On the other hand, for PNP, if emitter is connected to positive terminal with respect to base and the collector is connected to negative with respect to base, then PNP. Saturation region operation. If both the emitter and collector are made negative with respect to the base, then NPN transistor will operate in saturation region and work as an on switch. On other hand, when we talk about PNP transistor, in PNP emitter and collector are made positive with respect to base, then PNP transistor will operate in saturation region. Cut-off region operation. This is also very important difference between NPN and PNP transistor. For NPN transistor to operate in cut-off region, the emitter and collector are made positive with respect to base. For NPN transistor to operate in cut-off region, the emitter and collector are made negative with respect to the base. Ground signal. For the NPN transistor, the ground signal is low. For the PNP transistor, the ground signal is high. Means if you are talking about NPN, the ground signal will be low, on the other hand PNP will be high. Then now we are discussing about starting of conduction. NPN transistor starts conducting once the electrons enter the base region. PNP transistor start conducting once the holes enter the base region. Switching on or off. NPN transistor is switched on by applying a positive voltage at base terminal, while it is switched off by reducing the base voltage. PNP transistor is switched on by applying a negative voltage of base terminal and is switched off by applying in positive voltage. Direction of base current. This is the major difference between NPN and PNP. It's the direction will show which one is NPN and which one is PNP. Now listen carefully. The direction of base current in NPN transistor, the base current flow from base to ammeter. Another hand, for PNP transistor, the base current flow from ammeter to base. Direction of ammeter arrow. In the symbol of NPN transistor, the ammeter arrow is directed outward, and the other hand, the symbol of PNP transistor, the ammeter arrow is directed inward. Now we discuss the advantage of transistor and BJT. First of all, we discuss the advantage of transistor. The core use of transistors includes switching application or both amplification and switching. Second one, there is a kind of transistor that produce current flow depending on the amount of light shined open them. These are known as phototransistor. Third one is multiple emitter transistor are used is transistor logic, short form is TTL, and NAND logic gates. Fourth one is dual gate MOSFETs are used in RF mixer, multipliers and RF amplifiers where two controlled gates are required in a series. The next one is avalanche transistor can switch high currents in less than nanosecond transition times. Now BJT can cause a greater current flow from the ammeter to the collector when a small amount of current is passed through the base. Field effect transistor FET, known as a FET, act as a voltage control device. Field effect transistor have very high input impedance and it helps to run very little current through them. This is helpful for not causing the power source to the load down, as they are not disturbing the original circuit power elements to which they are connected. FET are cheaper and easier to manufacture, cause less loading. Heterojunction bipolar transistor HBT can provide faster switching speeds and are used in analog and digital microwave applications. This is used as a real time application of transistor. They are priceless to fabricate and can provide better lithographic yield. They are used in mobile and laser drivers and power amplifiers. Darlington transistors have a much higher ability to gain current because of the sensitivity it can pick currents from human skin, which is way it is used to create a touch sensitive button. The next one is Schottky transistor divert high input current and prevent the transistor from saturation. Now we discuss the advantage of BJT. These are the advantage of BJT, bipolar junction transistor. It has high frequency operation and bipolar junction transistor, high driving capacity. It can used as a digital switching application of BJT. Bipolar junction transistor are mainly used in switching and amplifier. Application of BJT includes radio transistors, audio transistor, televisions, computers, mobile phone, etc. Now we discuss the conclusion of PNP and NPN. From the above discussed, it can be concluded that are various difference between NPN and PNP transistor. Both of this transistor are widely used in different electronic applications like in switching, amplification, etc. Thus, the knowledge of this difference can help an individual to select the right and kind of transistor as per exact requirements. In the first lecture of transistor and bipolar junction transistor introduction, we discuss about what is the transistor, what is the symbol of transistor, and what is the difference between diode and transistor, what is BJT, in BJT what is NPN, what is PNP, what is the current flow between NPN and PNP, what is the difference between PNP and NPN, and now we completed this session, and next session we discuss about the operation of bipolar junction transistor. Thank you.